Why do we do delete rectangle angles? I think that you know, right? We are in C++. Nothing comes cheap. Nothing comes automatically. We need to hint the compiler that the compiler needs to do something more. So I didn't have time to prepare a presentation. Well, we are told in a way, it is quite generic, that the compiler needs to check size of the allocation pointed by PTR, and then calculate the number of elements accordingly, call the distractor on all elements sequentially, and then, of course, deallocate the heap memory allocated for PTR, which is a single operation. It's the entire block, right? Let's play with it a bit. An important note, nothing that I say here is applicable. I mean, don't use anything. It just, everything is compiler specific. It's just for general knowledge that you should forget. Okay, so let's take the first example. I have a class, a struct, by the way, with no members, okay, which size is probably 1 byte. And I want to allocate one single object, then 0 objects. Oh, how many 0 objects would cost in memory? We can check. And how many calls to distractor there will be? Oh, we may confuse the compiler or the runtime. I don't know. Then there is a function that we can call malloc usable size. What is the actual allocation that we got? So I'm calling here malloc usable size for all the options, and I get that for the single object I got 1 byte, for the 0 sized array 1 byte, for for 1 element 1 byte, and for 2 elements 2 bytes. How does it work for 0 size array? I mean, the size is 1. How the compiler distinguish between 0 size array and a single element array? It should, right? Okay, let's continue to another example. Now I have B. B holds a T, okay? Now T can be anything. I have a function play with allocations to print things. So in main, I can play with B of char, B of int, B of long, and B of string. Then I run the code with all the options, and I see that for long I get what I should expect. By the way, 0 elements is 1. Single element is 8. Makes sense. Maybe now something can be, but if it is for chars, no, the first one was for int, for chars. Again, we get 0 elements 1, single element 1. Okay. When we continue to string, we actually get call dump. Here it is with other sanitizer, but if I will remove other sanitizer, it will be a crash. And the reason is that we try to call malloc usable size on something that comes back and says, I cannot bring you the size for some reason. So to solve that, I'm adding an environment variable that you will see here called asin options equals check malloc usable size 0, which means if check size doesn't work, don't crash the program. Okay, and now the program doesn't crash, but when I ask what is the size of allocation for the string options, the answer is 0. Oh, what is going on? How would the compiler know how many items are there when I didn't get the actual allocation? Something looks quite wrong there. So we don't have it exactly as it works. Let's go back. How delete rectangle brackets work? So in fact, it is compiler specific, of course, but first, the compiler checks if the type is trivially destructible. If it is, it jumps to 4 because there isn't any need to call a destructor. But if it is not trivially destructible, then it takes the pointer PTR size of size t, bytes back. There is a size right before the array. Then the num elements are there. Then it takes the num elements, then it calls the destructor, and then it deallocates the entire size, including the size that was there. If we want to see it, we can just go and implement 2 functions, one for the trivially destructible case and one for the non-trivially destructible case. And for the non-trivially destructible case, we'll do the pointer arithmetic to go back and fetch the size. And we'll get the actual size. The actual size for the strings will go as we actually want. And now we have to forget that. Don't use it. It's not applicable. You forgot it. Thank you.
Really?